Antimatter is a really fascinating aspect of our universe. It is an impossible substance, being highly unstable and downright explosive, yet it shaped our universe in every way imaginable. When our universe first formed, antimatter and matter annihilated each other, leaving what was left of the matter to form into planets, stars, galaxies, nebulae, black holes, you name it. Now, the existence of antimatter, well, the beginning of time, obviously. But the prediction of its existence by humans started with Paul Dirac, whose hair kind of looks like Bill Murray's from Ghostbusters. Dirac wrote this really long formula describing the behavior of electrons, subatomic particles that carry electricity through all substances, and that formula is listed right here. If you don't understand this formula, don't worry. What's important is that for it to work, a particle that does the exact opposite of an electron must exist. So astrophysicists are kind of banking on the idea of antimatter because if it doesn't exist, their world would literally fall apart. This necessary particle is what we call a positron. Now, a positron is a positively charged subatomic particle with the same mass as an electron. Its sign is E+, to show that it has a positive charge and is the exact opposite of an electron. Positrons will react with normal electrons to make gamma radiation of photons, or light, through annihilation. Annihilation is exactly what it sounds like. When a particle and its antimatter equivalent come in contact, they explode. A pound of the stuff with a force explodes with a force of 19 megatons of TNT when annihilated. That's 3% of the power of Tsar Bomba, a bomb with 54,000 times the mass. Just because the Dirac's equation focused on the electron doesn't mean antimatter only has one particle to use. There is the antiproton, a subatomic particle with the same mass as a proton but a negative electric charge. Its symbol is P with a dash over it, and it doesn't release any known energy or radiation through annihilation. Antiprotons are the easiest antiparticles to make in a lab, so scientists use them a lot to test particle creation. There is also the antineutron, a subatomic particle with the same mass and charge as a neutron, but consists of antiquarks instead of quarks. For those who don't know, quarks are the building blocks of composite particles like protons and neutrons. So now we've got all the atomic particles we need to make an atom, but has anyone actually built an antiatom? Yes. In 1995, CERN physicists at the Low Energy Antiproton Ring used magnets to capture positrons and antiprotons and form into an atom of antihydrogen for 15 minutes before dissipating. What's cool about this is that in the future, humans could create an antimatter counterpart to molecules. I can't wait to get my hands on some anti-H2O.